explain about a project titled Plant Disease Classification Using Transfer Learning. Plant disease classification using the transfer learning. The global challenge of ensuring the crop health and the food security has spurred the development of innovative solutions. This project leverages the power of deep learning algorithms including the VGG19, Inception V3 and the Inception ResNet V2 to revolutionize the plant disease diagnosis. By harnessing the knowledge learned from the diverse image dataset, we aim to accurately classify a wide range of plant diseases from the images. The implications are profound. Disease identification empowers the farmer to take the targeted measure, preventing the widespread crop loss and fostering the sustainable agriculture. And the objective of our project is to create a robust plant disease classification system using the transfer learning with of VGG19, Inception V3, and ResNet V2. We aim to accurately identify and categorize a diverse range of plant diseases from the images, enabling the timely and targeted intervention. By harnessing the power of pre-trained deep learning models, we seek to enhance the disease detection accuracy and provide the valuable insight for the farmers and the researchers. Through the integration of this advanced algorithm, our goal is to contribute to improved crop health, increased yield, and sustainable agriculture practice. Ultimately, this project aims to empower the agriculture stakeholder with an effective tool to mitigate the disease-related risk, optimize the resource allocation, and ensure the food security for growing the global population. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Ankunda with version of 3.7, Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. And these essential Python libraries are imported likely of TensorFlow, Keras, NumPy and the Flask to facilitate the data manipulation, image processing, deep learning and the web application development. And the second one is importing the dataset. Here, collecting a comprehensive dataset containing of various plant diseases in the form of images and the corresponding label for training and evaluation. And the next step is image scaling and processing. Pre-processing the images by resizing them to the consistent size, ensuring the uniformity for the model training. Normalize the pixel value to bring them with a specific range with a better convergence during the training. And the next step is splitting into the training and the testing. Divide the pre-processed data set into the training and the testing set, ensuring the model performance is evaluated on unseen data during the testing. And the next step is building the model. Here various machine learning models are developed. The first one is VGG90. It is a deep convolutional neural network for the image classification. Here it can learn the intricate feature from the plant disease images, capturing the subtle pattern indicating of the specific disease. VGG19 deep structure allow it to recognize both the low-level features and the high-level features in the plant images. Transfer learning with the VGG19 involves utilizing a pre-trained way on the large dataset to expedite the learning on the plant disease dataset. And the next one is Inception V3. Inception V3 is a convolutional neural network architecture designed for the efficient use of computational resources and the improved accuracy. Its Inception module uses the multiple filter sizes, capturing the feature at the different scale and enhancing the model's ability to identify the disease-related patterns. And it excels at learning the hierarchical feature and handling the variation and the disease manifestation within the plant images. And the transfer learning with the Inception V3 involves leveraging its learned feature from the broader image domain and the fine-tuning its parameters for the plant disease classification. And the next one is Inception ResNet V2. It is a fusion of Inception and the ResNet architecture, combining the strengths with the improved performance. It includes the residual connection for elevating the vanishing gradient problem and facilitating the deep network training. Its architecture aids in capturing both the fine-grained and the highly level features, making it effective for distinguishing the plant disease pattern. Transfer learning, where the inception resonate, enable the leveraging its learned representation and further adopting them to the nuances of the plant disease classification. And the next step is training the model. Train each selected model using the training data set to learn the distinctive features of the different plant disease. And the next step is user gives the input. The create a web application using the Flask as a Python web framework, allowing the user to upload the plant image for the disease classification. And the next step is the given input is pre-processed for prediction. The pre-process, the user provided input image to match the format used during the model training, including image scaling and normalization. And the next step is trained model is used for the prediction. Utilize the pre-processed model input image to make the prediction using the trained model for the disease classification. Each model will assign the probability distribution over the different disease classes. And the last one is final outcome is display. Display the prediction outcome indicating the likely plant disease among the corresponding confidence score for each model. The user receives the insight into the potential disease affecting the plant, enabling the informed action for the disease management and the mitigation. And the next step is the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The static folder containing of images, assets, JavaScript and the CSS files within it. And the template folder containing of HTML documents, it typically includes form, index, notebook, result, signing and sign-up pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handles the server-side operations, such as processing the user requests, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the HY files include the algorithm information, and these loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data and performing the specific operation. And the signup.db is a file appeared to be the database used to store the user information. And the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to change the location of the disk to F because our code folder is present in FS. Then write a command cd space and paste this code folder path. By this it will change the current directory to the code folder path. And then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script to perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address. Like this, we need to copy this local link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I am opening the Google Chrome and pasting this link, and then click on the enter button. Here we can see the title of the project containing a form and sign up buttons. Click on the sign up button. Here it will redirect it to the sign up page containing of some details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect it to the sign in page containing of username and password and those details that need to be filled. And then click on the login button. Here it will redirect it to this page containing of the choose file and upload buttons. The choose file button, we need to select any one of this image and then click on the open button and then click on the upload button. Here it will redirect it to the result page and giving the detection this is the uploaded image and detected as of Apple scab. And these are the symptoms of Apple scab and these are the treatment that need to be followed to prevent this Apple scab. And by using the try again button, here we redirect it to this index file, and by using the choose file button, we upload the another image too. I'm clicking on open button and then click on the upload button. Here it redirected to the result page and detected the plant disease as of healthy apple. In this way, we can detect the plant disease using the transfer learning. And in conclusion, Our project has demonstrated its potential to revolutionize the agriculture practice by accurately identifying and classifying over of 35 plant diseases. We have paved the way for proactive disease management and effective intervention. The integration of advanced deep learning holds the promise of safeguarding the global food security, optimizing the crop yield, and fostering the sustainable farming.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.